Hello, geometry students. Today we're going to be talking about angle bisectors. And remember, we have spoken before about segment bisectors. So let's remember what a segment bisector is. A segment bisector is anything that bisects a segment. It's a point, line, segment, ray, any of those things that goes through the midpoint of a segment and divides that segment into two congruent parts. So any of those things that divides a segment into two congruent parts is called a segment bisector. So in this example, CD is a segment bisector because it's bisecting a segment AB, cutting it into two congruent parts. Or you could say point M or any of these segments. This bisects the segment. Well, an angle bisector is very similar, but there's something that's different. With an angle bisector, it can only be a ray, and it is going to be a ray that starts at the vertex and goes out into the interior points of that angle. I'm going to model that for you. So it's a little more picky of the definition, but the thing that's the same is it bisects. In other words, it cuts the angle into two congruent angles. So let me do an example for you here. Here is a ray KM. So the starting point for the ray is at the vertex, and it goes through M on its way to infinity. Because remember, an angle looks finite, but this arrow means this side of the angle goes for infinity this way. This side of the angle goes for infinity this way. So the ray that bisects is also infinite. And it starts at the vertex and goes into the interior of the angle. So KM bisects angle LKJ because it divides LKJ into two congruent parts, two congruent angles. So I want you to pause, write down the definition for an angle bisector, write that in your notes, and then see if you can decide what is the angle bisector for each of these diagrams below. Let's look at this one first. So pause and write down the name of the angle bisectors for each of these diagrams. So an angle bisector is a ray that divides an angle into two congruent angles. So I see these are two congruent angles, and I see this big black angle, AOB, is getting chopped into two congruent parts by ray OP. Ray OP is the angle bisector of angle AOB. All right, how about this diagram? Again, I see this angle is congruent to this angle, so I see that angle ABC is getting bisected, cut into two congruent angles by ray BD. All right, how about this diagram? I see these are two congruent angles, and so be careful, write down what you think the angle bisector is. Remember, the angle bisector will be a ray. It will start at the vertex and go into the interior of the angle. So remember, even though this looks like a polygon, if I'm talking about this angle, then this goes on forever this way, this goes on forever this way, and the bisector would be a ray WY. And oh no, I have more. So who is the angle bisector in this diagram? Don't get confused by all the extraneous lines and information in the diagram. You see that these two little angles are congruent. Angle CBU is congruent to UBZ. And so we see that angle CBZ is getting bisected by ray BU. The ray starts at the vertex and goes into the interior of the angle and shoots out for all of infinity. All right, and now here in the final diagram, where is an angle bisector? Again, ignore the extraneous information here. The only thing that's important for this particular question is this angle is congruent to this angle. Angle SOP is congruent to angle POT. So angle SOT is getting bisected by ray OP. Okay, so now let's practice a problem with the knowledge of what a bisector is. Pause the video and solve this on your own paper. We're given that AY bisects XAZ. And the definition of a bisector tells us that if you're bisecting an angle, you're cutting it into two congruent parts. And if XAY is 72, then YAZ would also have to be 72. Pause the video, solve this on your own paper, and then press play. We're given that BD bisects ABC. The minute you know that BD bisects ABC, I recommend you write a little mark on your diagram to help you remember that fact. Because if BD bisects this big angle, that means by definition, a bisector is a ray that divides a big angle into two congruent parts. So you could put those congruent marks right away the minute you know you've got a bisector. And when you mark your diagram, it helps the problem start to solve itself. Because if those are congruent, then we know the definition of congruent angles. Congruent angles have equal measurements. So we're going to use the definition of an angle bisector, and then we're going to use our knowledge of what congruent angles are. To set those equal and solve, we can subtract 5x from both sides, subtract 50 from both sides to get all our variables on the left and all our numbers on the right, and then divide by -3 to do our inverse operations to get x alone, and then plug it in to find our angle measurements. So we know these guys are going to be equal, and they add together by angle addition, 160. So pause, solve this on your own paper using your knowledge of what an angle bisector is, and then press play. Earlier we discussed that OP is the angle bisector of SOT, which means these two angles are congruent. We're given that they're congruent. So the angle bisector is OP. And then we are told that if we know that's an angle bisector, then we know these have to be the same. We don't know what they are, but let's call them both X. We are told that ROT, the whole huge angle, is 143. And so we can use our combination of our knowledge of what an angle bisector is and the angle addition postulate to create our equation. 57 plus 2x have to add up to the whole. Part plus part plus part equals the whole. And then we can do our inverse operations to get x alone. And since the measurement of that angle is x, we know the measurement is 43 degrees. Pause the video, solve for x, and then press play for the solution. We are told QS is the ray that bisects the big angle RQP, the big orange. And since we know this is a bisector, the definition of bisector means it cuts the big angle into two congruent parts. So if this blue one is 6x plus 4, then this one also has to be 6x plus 4. And if they're both 6x plus 4 and the whole thing is 13x minus 1, we can write our equation. We can combine our like terms and do our inverse operations to get x alone. And that is it for angle bisectors. So I will leave you with this adorable kitten, and I will wish you a great day.